Okay, so now that we're back, let's go ahead and review the different types of in behavior. So like I said, when we find in behavior, we're going to find the sign of the leading coefficient and whether the degree is even or odd. So we're going to write down all the different possibilities. If you have a positive leading coefficient, so I'm going to put LC, and then an odd degree. So you go through all of that, you find that it's a positive leading coefficient and it's odd. Well, the way that I remember this is that an odd, like a 3, 5, 7, 9, is a cubic. And since it's positive, that means it wasn't reflected. So it's still increasing from left to right. The reason why I think it's beneficial to think of those pictures because it's going to help you write your in behavior. So in Algebra 2, you guys wrote this as x arrows negative infinity, y arrows something. But in pre-cal, we are going to write this in limit notation. So I'm going to write this as limit over x arrow negative infinity. That's the limit as x approaches negative infinity of f of x. And as I go left, an positive odd degree is going to go down to negative infinity. Then the limit as x approaches positive infinity of f of x. So as I go to the right of f of x, it's going to equal positive infinity. So if I go to the right of a positive odd, it's going up. But then I could have a negative leading coefficient, but still odd degree. So it's still kind of like my cubic or linear function, but instead of increasing from left to right, it's decreasing from left to right. Okay, so what that changes is now when I do the limit as x approaches negative infinity of f of x, remember when we say x approaches negative infinity, that means I'm going to the left. So if I go to the left of this graph, it's pointing up to positive infinity. Then the limit as x approaches positive infinity of f of x. So if I'm going right, so that's what that means, limit as x approaches infinity of f of x. So if I go to the right, the graph is going down to negative infinity. Okay, so then we also have a positive leading coefficient, like the first one, but now instead of odd degree, let's talk about even degree. So if it's an even degree, that means that that's kind of like a quadratic, right? Like a 2, 4, 6, 8. So that's going to be a positive even, so an upward facing quadratic. Let's see. Okay, so positive leading coefficient, even degree. So that means it's kind of like a quadratic because it's even, 2, 4, 6, 8. Positive is going to be facing up. So the limit as x approaches negative infinity of f of x. So the limit as x approaches negative infinity of f of x, ak to the left, that graph on the left is pointing up to positive infinity. And then the limit as x approaches positive infinity of f of x. So as I go to the right of that quadratic, the graph is still pointing up to positive infinity. Then the last scenario we could have is a negative leading coefficient. So a negative leading coefficient, and it's odd degree. So if it's a negative leading coefficient, not odd degree, that should be even. So a negative leading coefficient with an even degree, that means that my even degree, which is kind of like a quadratic, 2, 4, 6, 8, negative means that it's reflected over, so now it's facing down. So the limit as x approaches negative infinity of f of x, so as I go to the left, I'm pointing down to negative infinity. And the limit as x approaches positive infinity of f of x, so as I go to the right, the graph is also pointing down. And these are all in behaviors you're going to have to know without a calculator because this will not be with a calculator. A way to remember that I personally like is that evens follow the same behavior. Right? See how these are both even degrees and they follow the same behavior? And it's the same behavior as the sign of the leading coefficient. If it's positive infinity, positive infinity. If it's negative infinity, negative infinity. Odds do the opposite, and the way you remember which one's which, Well, odd positive increases, so it starts at negative infinity, ends at positive infinity. And negative odd decreases, so it starts at positive but ends negative because it's decreasing. So with all that being said, let's do a couple examples with just in behavior, and then I'll finish with a couple examples of everything. So the first example, or first two examples we're going to do, we are going to find the in behavior in limit notation. So that's going to be the instructions for the first few. Find the in behavior in limit notation. So the first one, let's do g of x is equal to negative 3x squared plus 2x to the 7th plus 4x to the 4th. So the first thing I want you asking yourself when you look at this is this in factored or standard form? Because based off if it's in standard form or factored form, it's going to change how you find your leading coefficient and your degree, which is the two things you have to know to find the in behavior. So hopefully you guys are looking at this and you say, oh yeah, that's standard form. The reason why I know that is because there's no parentheses and this is clearly not factored. And we don't have to factor it because they're not asking us for x-intercepts. We are just going to find the in behavior in limit notation. So in standard form, to find the leading coefficient and the degree, it's based off the highest exponent. So the highest exponent. So don't just always take the first one, okay? Because in this case, you would get it wrong. The highest exponent is actually 7. So that's going to be my degree. Since I circled 7 as my degree, what you care about for degree is whether it's even or odd. Well, 7 is an odd number. So this is an odd. And then your leading coefficient is the number in front of the term with the highest exponent. So the number in front is my leading coefficient. So this plus 2 is my leading coefficient. So 2, once again, I don't care necessarily that it's a 2. I care if it's positive or negative. So that 2 has a plus sign in front of it. So this is a positive odd. So a positive odd degree, which essentially means I'm just going to copy down this answer because a positive odd is kind of like a cubic or a linear that increases over time. So I have the limit as x approaches negative infinity. Technically of g of x, if you put f of x there, that's fine. Honest mistake. So as I go left, the graph is pointing down, and the limit as x approaches positive infinity of g of x. So as I go right, the graph is pointing up. And that's the in behavior. So let's do one more example, and then we'll go on to all the rest of the stuff as well, in addition to in behavior. So the last example of just in behavior, I'm going to do f of x equals 2x cubed, x plus 5 in parentheses, then squared, and then 3 minus x in parentheses with a cube out back. So 2x cubed, parentheses, x plus 5 squared, parentheses 3 minus x cubed. So this one is not in standard form, right? Do you guys see how it's in parentheses and all these are just factors? So that's factored form. So we need to find our degree and our leading coefficient. So our degree in factored form is we're going to add up all the exponents. So everything does have an exponent here. Remember, if it doesn't, it's assumed to be 1. Okay, so let's say like this last one didn't have 1. That'd be 1. Okay, but since it does, it's going to be a 3. So to add up all the exponents, I'm going to take 3 plus 2 plus 3, and that is 8. So that is my degree. Once again, I don't care that the degree is 8. I care if the degree is even or odd. And since 8 is an even number, I have an even degree. Then to find my leading coefficient, I'm going to multiply all leading coefficients of x. So I'm going to do 2 times 1 times negative 1. But you also need the exponents into account. So this 2 does not have an exponent. So 2 times 1 in front of this x but then you have to square it, then times -1 in front of that x, but then I have to cube it.